Good morning, students. Now let us discuss the problems on friction. So here this problems is, it states that a body is supported on a rough, this is a rough inclined plane of inclination alpha. So this body is being supported by a force acting along the plane, and we name that force which is acting along the plane as P. So it is just supported, this body is just supported by this force P. So therefore this body is on the point of moving downward. So therefore the force of friction, which always acts opposite to the direction in which the body has tendency to move. If the body has tendency to move downwards, so the force of friction will act upward. So mu r also will act upward. So along this, the forces along the plane now will be P, which just supported this body, and together with the frictional force, that is mu r, and W is the weight of this body acting vertically downward. So resolving these forces along the plane and perpendicular to the plane, we have the result part of this, because here you have alpha. Result part of this force W, it is W sine alpha along the plane, and perpendicular to the plane it is W cos alpha, and R is the normal reaction perpendicular to this body. So here, as in this case, the first case, okay, because the body is supported on a rough inclined plane by a force acting along the plane. So this is the force P, which is acting along the plane. So since the body has a tendency to move downwards, so we resolve the forces along the plane, resolving the forces along and perpendicular to the plane. Refer to figure 1. Okay, so here along and perpendicular, what are the forces along the plane? These are the forces W sine alpha, mu r and P. But mu r and P, they are in the same direction, so we can write P plus mu r is equal to W sine alpha. Name this as equation 1. And what are the forces perpendicular to the plane? These are the forces perpendicular to the plane, that is R, the normal reaction, and the result part of this W, that is W cos alpha. So we have R is equal to W cos alpha. Name it as equation 2. So substituting the value of R in 1, so therefore 1 implies, now with the help of equation 2, we have P plus mu W cos alpha. Instead of R, you replace it by W cos alpha is equal to W sine alpha. So this implies that P here equal to, bring this to this side, so you can take W common. So sine alpha minus mu cos alpha. But we know that mu here is equal to tan lambda, where lambda is the angle of friction. So from here, this implies that you replace this mu by tan lambda. So P is equal to W sine alpha minus tan lambda into cos alpha. Okay, so which is, replace tan lambda by sine lambda upon cos lambda. So you get W into sine alpha cos lambda minus cos lambda into cos alpha. Sorry, it should be, here it should be sine lambda cos alpha divided by cos lambda. So this is equal to W into sine lambda cos lambda minus sine alpha cos lambda minus sine lambda cos alpha. It gives you sine of alpha, that is sine A minus B from trigonometry, divided by cos lambda, which is equal to, implies that P here is equal to W sine of alpha minus lambda into secant lambda. Name this as equation 3. So this is the case when a body is being supported by a force acting along their plane. Now supposing the greatest magnitude of this force P is being double, now is increased to 2 times of this P, then find the inclination of the force, that is alpha. So in that case, if you increase this force P to twice P, then that force which is still acting along the plane, then in figure 2 you can see that the body has in this case the body has a tendency to move upwards. So if it is moving upwards, the force of friction mu r will act downward, and as in the case of in figure 1, resolving the forces W along and perpendicular to the plane, you have W cos alpha here and W sine alpha, sorry, W W sine alpha here along the plane together with this force of friction mu r. R is the normal reaction perpendicular to plane acting upwards, whereas this is acting in this direction, that is W cos alpha. So refer to, now when the force is being increased to twice P, so in this case when the body or this one is in the position of moving up, so by applying this force P prime, which is P prime is equal to twice of P, then and it is acting along the plane, so therefore you have here P prime will be is equal to twice of, so when it is acting upwards, so resolving the forces along and perpendicular to the plane, we have, what are the forces along the plane? They are W mu r plus W sine alpha, this one is equal to twice P prime. And perpendicular to the plane, you have R is equal to W cos alpha. Substitute the value of R here. So name this as 4 and this as 5. Using 5 in 4, we get mu times of W cos alpha plus W sine alpha is equal to it is equal to P prime. P prime, because P prime is 2 times double of the force P, first force that we just supported the body. So this implies that W into or P prime is equal to W times of mu cos alpha plus sine alpha is equal to, replace this by tan lambda, so W into tan lambda cos alpha plus sine alpha. So this is equal, but tan lambda, replace it by sine lambda upon cos lambda, so you'll get W into sine lambda cos alpha plus sine alpha cos lambda divided by cos lambda, and the formula for this is nothing but sine of alpha plus lambda into W divided 1 upon cos, you can replace it by secant lambda. So you have here P prime is equal to this, but according to the question, what is P prime? P prime is equal to 2 times of P. What is P? P here is equal to, as you can see here, P prime is double of the force P acting along the plane, that is P, twice P. So you replace this by twice P. Twice P is equal to W sine of alpha plus lambda into secant lambda. Now this P, what is P from equation 3? It is 2 times of W sine of alpha minus lambda into secant lambda is equal to W sine of alpha plus lambda into secant lambda using this equation 3. Replace P by this equation. Now this W cancel and then secant cancel. This implies that 2 is equal to sine of alpha plus lambda divided by sine of alpha minus lambda. So cross multiply this, you can write this as 2 times of, cross multiply this, expand this, sine of alpha a minus b using that formula. So you have twice sine alpha cos lambda minus twice cos alpha sine lambda is equal to sine alpha cos lambda, expand this, plus cos alpha sine lambda. And this is equal to, because one part you bring it to this side, this cos here, if you bring it to this side, bring this sine alpha cos lambda to this side, it will become minus, so it will get subtract with this. What remains from the left hand side, it is sine alpha cos lambda is equal to, bring this to this side, you'll get 3 times of cos alpha sine lambda. So from here, this implies that then now you divide here, divide both sides by cos lambda. Sorry, here you should have, this is sine lambda, not cos. So divided both sides by cos lambda. So what remained here is, when you divide by cos lambda, you will get only sine alpha by sine alpha only divide by cos alpha sine lambda, I mean. So here you will get this cos alpha. When you divide here, it will become tan alpha, and here it will get cancelled. Whereas when you divide by cos lambda from both sides, this one will get cancelled. So what remains here, it is tan alpha, and from here it will remain as tan lambda, because that cos lambda will get this cos alpha will get cancelled while dividing. So I'll just write here dividing both sides by cos alpha sine cos lambda. So what remains there is that tan alpha is equal to 3 tan lambda, which implies that alpha is equal to tan inverse, or alpha is called tan inverse of, or 3 tan lambda. But tan lambda, we know it is equal to mu, so you can write it as tan inverse of 3 mu, because mu is equal to tan lambda. I hope it is clear to you.